Welcome to NCM110, Nursing Informatics. Computer System. Typically, computer systems are composed of many different components that enable the user to communicate with the computer and with other computers to produce work. The group of required and optional hardware items that are linked together to make up a computer system is called its configuration. When computers are sold, many of the key components are placed inside a rigid plastic housing or case, which is called the box. What can typically be seen from outside is the box containing the internal components and the peripherals such as keyboard, mouse, speakers, monitor, and printer. Computer hardware, defined as all of the physical components of a computer. A computer is a machine that uses electronic components and instructions to the components to perform calculations, repetitive and complex procedures, process text, and manipulate data and signals. Computer technology has evolved from huge room-sized electronic calculators developed with military funding during World War II to palm-sized machines available to virtually everybody. Today, computers are encountered in most areas of people's lives, from the grocery store and the movie theater to the power grid, from the bedside alarm clock to the automobile accelerator, and from infusion pumps to heart monitors, patient record systems, radiology machines, diagnostic devices, order processing systems, and all kinds of machines in the operating room. Computer processors are employed so widely that today's society could not function without them. Computer hardware. The basic hardware of a computer composes the computer's architecture and includes the electronic circuits, microchips, processors, random access memory or RAM, read-only memory or ROM, and graphic and sound cards. These are attached to a component called a motherboard. The motherboard is a square or rectangular board with circuits into which are plugged the main electronics of the computer. Okay, let's talk about the different hardware. So we have the RAM. So your RAM is a temporary storage area for program instructions and data that is being processed. It is only active when computer is on. We have your ROM. It is a permanent. It remains when power is off. Example, startup instructions for computer. We have the CPU or the brain of the computer. We have the motherboard. It is a main printed circuit board or PCB found in computers and other expandable systems. It holds many of the crucial electronic components of the system, such as the central processing unit or your CPU, and of course the memory, and it provides connectors for other peripherals. Graphics card. A video card, which is also called a graphics card, display card, graphics adapter, or display adapter. It is an expansion card which generates a feed of output images to a display device, such as your computer monitor. We have the sound card. It is an internal expansion card that provides input and output of audio signals to and from a computer under control of computer programs. Hard disk. A hard disk drive, hard drive, or fixed disk is an electromechanical data storage device that stores and retrieves digital data using magnetic storage and one or more rigid rapidly rotating platters coated with magnetic material. Flash drive or thumb drive. A USB flash drive is a data storage device that includes flash memory with an integrated USB interface. It is typically removable and rewritable. Modem or router. A modem is a box that connects your home network to the wider internet. A router is a box that lets all of your wired and wireless devices use that internet connection at once and also allows them to talk to one another without having to do so over the internet. Monitor. A computer monitor is an output device that displays information in pictorial form. Printer. A printer is a device that accepts text and graphic output from a computer and transfers the information to paper, usually to standard size sheets of paper. Printers vary in size, speed, sophistication, and cost. In general, more expensive printers are used for higher resolution color printing. Personal computer printers can be distinguished as impact or non-impact printers. Let's talk about impact printer. Early impact printers work something like an automatic typewriter, with a key striking an ink impression on paper for each printed character. The dot matrix printer was a popular low-cost personal computer printer. It's an impact printer that strikes the paper a line at a time. Non-impact printer. The best known non-impact printers are the inkjet printer, of which several makes of low-cost color printers are an example, and the laser printer. The inkjet sprays ink from an ink cartridge at a very close range to the paper as it rolls by. The laser printer uses a laser beam reflected from a mirror to attract ink, or also called your toner, to selected paper areas as a sheet rolls over a drum. Input and output. We have input devices. These devices allow the computer to receive information from the outside world. Output devices. These devices allows the computer to report its results to the external world. Output devices are defined as any equipment that translates the computer information into something readable by people or other machines. The most common input devices are the keyboard and the mouse. Others commonly seen on nursing workstations include the touch screen, light pen, voice, and scanner. A touch screen is usually both an input and output device combined. Electronics allow the computer to sense when a particular part of the screen is pressed or touched. In healthcare computing, many medical devices serve as input devices. For example, the electrodes placed on a patient's body provide input to the computerized physiologic monitors. The oximetry device placed on a patient's finger uses light waves to detect impulses that are sent to a computer and then interpreted as oxygen levels in the blood. Output can be in a form of text, data files, sound, graphics, or signals to other devices. The most obvious output devices are the monitor or your display screen, and of course our printer. Other commonly used output devices include storage devices such as the USB drive, or also known as your flash or thumb drive, and of course our optical media. In healthcare settings, a variety of medical devices serve as output devices. Heart monitors are output devices recording and displaying heart rhythm patterns and initiating alarms when certain conditions are met. Volumetric infusion pump output includes both images on a screen and fluids infused into the patient's body. The pump delivers a specific volume of IV fluids based on commands that the nurse inputs so that the ordered fluid volume will be infused in the correct time period. Special purpose machines designed to do only a very few different types of tasks have also been developed. A category of special purpose computers includes the tablet, personal digital assistants, and smartphones. Today, 5 basic types of computers are generally recognized. Each type of computer was developed as the computer industry evolved, and each was developed for a different purpose. The basic types of computers include the supercomputer, the mainframe, the microcomputer, the handheld, and PDAs. Supercomputers. The largest type of computer is the supercomputer first developed by Seymour Cray in 1972. The early supercomputer research, development, and production were carried out by Cray Corporation or one of its affiliates. A supercomputer is a computational-oriented computer specially designed for scientific applications requiring a gigantic amount of calculation. To be useful, must be processed at super fast speeds. The supercomputer is truly a world-class number cruncher, designed primarily for analysis of scientific and engineering problems and for tasks requiring millions or billions of computational operations and calculations. They are huge and expensive. Supercomputers are used primarily in such work as defense and weaponry, weather forecasting, advanced engineering and physics, and other mathematically intensive scientific research applications. So this is an example of a supercomputer. Mainframes. The mainframe computer is the most common, fast, large, and expensive type of computer used in large businesses, including hospitals and other large healthcare facilities, for processing, storing, and retrieving data. It is a large multi-user central computer that meets the computing needs of large and medium-sized public and private organizations. Virtually, all large and medium-sized hospitals, for example, we have 300 beds and up, have a mainframe computer to handle their business office operations. Mainframes are used for processing the large amount of repetitive calculations involved in handling billing, payroll, inventory control, and business operations computing. For example, large volume sales businesses like grocery store chains and the big box stores have mainframe computers tracking all sales transactions. In fact, the machines and software that process transactions in high volume businesses are known as Transaction Processing System or your TPS. The information nurses chart on patients in inpatient care facilities can be viewed as transactions. For example, every time a nurse charts a medication, the charting records use of one or more drugs. That charting in turn is transmitted to the pharmacy so that one item of drug in inventory can be decreased. So this is an example of mainframe. Microcomputers or personal computers. Although mainframe computers provide critical service to the healthcare industry, much smaller computers are also an essential part of healthcare computing systems. Computers designed to support a single users are called microcomputers or personal computers, much smaller and less powerful than a mainframe. PCs were designed to be used by one person at a time. In hospitals, they are used for an increasing number of independent applications, as well as serving as an intelligent link to the program of the mainframe. Hospital nursing departments use PCs to process specific applications such as patient classification, nurse staffing and scheduling, and personal management applications. Microcomputers are also found in education and research settings where they are used to conduct a multitude of special educational and scientific functions. Desktops are replacing many of the mainframe attributes. Desktops can serve as standalone workstations and can be linked to a network system to increase their capabilities. This is advantageous since software multi-user licensing fees are usually less expensive per user than having each user purchase his or her own copy. So these are examples of our personal computers. Handheld computers or personal digital assistants. Handheld computers are small, special function computers, although a few full-function handheld computers were introduced in the late 1990s. Even though of smaller size than the laptop and notebook microcomputers, some have claimed to have almost the same functionality and processing capabilities. However, they are limited in their expansion possibilities. Their ability to serve as full participants in the office network, and the peripherals they can support. More popular are the palm-sized computers, including personal digital assistants, which are the smallest of the handheld computers. The PDA is a very small, special function handheld computer that provides calendar, contacts, and note-taking functions, and may provide word processing, spreadsheet, and a variety of other functions. So this is an example of your PDA or your handheld computers. We call it right now your tablet or your iPad. Software computer system. Software is the general term applied to the instructions that direct the computer's hardware to perform work. It is distinguished from hardware by its conceptual rather than physical nature. Hardware consists of physical components, whereas software consists of instructions communicated electronically to the hardware. Software is needed for two purposes. First, computers do not directly understand human language, and software is needed to translate instructions created in human language into machine language. At the machine level, computers can understand only binary numbers, not English or any other human language. Second, packaged or stored software is needed to make the computer an economical work tool. Theoretically, users could create their own software to use the computer. However, writing software instructions, or what we call programming, is extremely difficult, time-consuming, and for most people, it's tedious. It is much more practical and economical for one highly skilled person or programming team to develop programs that many other people can buy and use to do common tasks. Software is supplied as organized instruction sets called programs, or more typically as a set of related programs called a package. Categories of software. There are three basic types of software. We have your system software, utility programs, and application software. System software boots up, starts up, and initializes the computer system, controls input, output, and storage, and controls the operations of the application software. Utility software consists of programs designed to support and optimize the functioning of the computer system itself. Application software includes the various programs that users require to perform day-to-day tasks. They are the programs that support the actual work of the user. Some users claim a third type of software called utility programs. These are programs that are used to help maintain the system, clean up unwanted programs, protect the system against virus attacks, and access the World Wide Web. Sometimes it can get confusing as to whether programs are utility programs or system software, because system software packages today usually include a variety of utility programs with the basic system software and packages. System software. System software consists of a variety of programs that control the individual computer and make the user's application programs work well with the hardware. System software consists of a variety of programs that initialize or boot up the computer when it is first turned on, and thereafter control all the functions of the computer hardware and application software. System software helps speed up the computer's processing, expands the power of the computer by creating cache memory, reduces the amount of confusion when multiple programs are running together, cleans up the hard drive so that the storage is managed efficiently, and perform others such as management tasks. Basic input or output system, or what we call your BIOS. The first level of system control is handled by the basic input-output system, or your BIOS, stored on a ROM chip on the motherboard. The software on the BIOS chips is the first part of the computer to function when the system is turned on. It first searches for an operating system, or your OS, and loads it into the RAM. Given that the BIOS consists of a set of instructions permanently burned onto a computer chip, it is truly a combination of hardware and software. Programs on chips are often called firmware because they straddle the line between the hardware and software. For this reason, many computer engineers make a distinction between firmware and software. From that perspective, the OS is actually the first level of system software. Operating system. So an OS is the overall controller of the work of the computer. The OS is software loaded from the hard drive into RAM as soon as the computer is turned on. While the firmware cannot be upgraded without changing the hardware chip, the OS can be upgraded or entirely changed through software. The user can simply delete one system of OS files from the hard drive and installs a new OS. Most users purchase a computer with the OS already installed on the hard drive. However, the OS can be purchased separately and installed by the user. OS handle the connection between the CPU and peripherals. The connection between the CPU and a peripheral or a user is called an interface. The OS manages the interfaces to all peripheral hardware, schedule tasks, allocates storage in memory and on disks, retrieves programs and data from storage, and provides an interface between the machine and the user. Utility software. They do this by adding power to the functioning of the system software or supporting the OS or application software programs. As such, utility programs are sort of between system software and application software. Although many writers identify this software as part of the systems called software category. 6 types of utility software can describe the majority of utility programs, although there is no formal categorization system for such programs. Utility software. It is composed of security software, disk management utilities, backup utilities, screensavers, archival software, and programming environment support programs. Security software including primarily an antivirus, firewall, and encryption programs protect the computer and its data from attacks that can destroy programs and data. Antivirus utilities serve primarily to guard against malicious programs inadvertently accessed, usually through email or downloads from the internet. Disk management utilities are designed to help the user keep hard disk space clean and efficient. They do this by analyzing use of disk space, defragmenting the drive, and deleting duplicate files if the user so commands. Over time, as users store and delete data and programs, information on the disk may become scattered across the disk in an inefficient or fragmented way. The defragmenter moves data around on the disk so that small empty spaces are eliminated and data and programs are relocated to better use the available space. These programs can also compress data to free up disk space, partition a disk so that the user has more control on where different types of informations are stored, and clean up disk by eliminating unnecessary data and information. Backup utilities serve to help the users back up their data. Applications programs may be backed up, but usually that is not necessary because legal copies of programs can be reloaded by the person who bought the license. Screensavers are computer programs that either blank the monitor screen or fill it with constantly moving images when the user is away from the computer but does not turn it and completely off. They were originally developed for old technology screens, what we call your CRT or cathode ray tube screens or plasma screens that would be damaged by having the same image on the screen for a long period of time. Modern computer screens have different technology and so do not suffer that risks. Archival software usually performs at least two functions. First, it compresses information in files to be archived and then stores them in a compressed form in some long-term storage device. For Windows, programs such as WinZip and WinRAR are well-known archival utilities. When the files are retrieved, software must be used to unpack or decompress the data so that it can be read. Terms used to describe the data compression performed by archival software include packing, zipping, compressing, and archiving, as well as unpacking, unzipping, de-archiving, and extraction. The compression can sharply reduce the size of large files such that it can be made small enough to email to another person or location. Programming environments support programs used by program developers to support their programming work or to run their programs. Computers cannot read or understand English or any other human language. Common software useful to nurses. In most hospitals, most software systems used by nurses are based in a hospital information system. The HIS is a multi-purpose program designed to support many applications in hospitals and their associated clinics. The components nurses use most include the electronic medical record for charting patient care, admission discharge transfer or ADT, systems that help with patient tracking, medication administering record or MAR, software supplies inventory systems through which nurses charge IVs, dressings, and other supplies used in patient care, and laboratory systems that are used to order laboratory tests and report the results. Free software. Free software is defined by the FSF in terms of 4 freedoms for software users: to have the freedom to use, study, redistribute, and improve the software in any way they wish. A program is only free software in terms of the FSF definition if users have all these freedoms. The FSF believes that users should be free to redistribute copies either with or without modifications, either gratis or through charging a fee for distribution to anyone, anywhere without a need to ask or pay for permission to do so. Open source software. Open source software is any software satisfying the Open Software Initiative's definition. The open source concept is said to promote software reliability and quality by supporting independent peer review and rapid evolution of source code, as well as making the source code of software freely available. In addition to providing free access to the programmer's instructions to the computer in the programming language in which they were written. Many versions of open source licenses allows anyone to modify and redistribute the software. So these are the common OSS or FS licenses. We have your GNU GPL, GNU Lesser General Public Licenses. We have the modified BSD license, the W3C Software Notice and License, MySQL or MySQL Database License, the Apache License, the GNU Free Documentation License, and the Public Domain. OSS or FS applications. So these are the most common. For our operating system, we have Linux. For our web browser, we have your Chrome or Firefox. For email client, we have the Thunderbird. For word processing or integrated Office Suite presentation tools, we have your OpenOffice. For healthcare applications, we have the GenoMed, we have the OpenEHR, we have the OpenEMR, and OpenMRS. The GenoMed project builds free, liberated open source EMR software in multiple languages to assist and improve longitudinal care, specifically in ambulatory settings, that is in terms of multi-professional practices and clinics. It is made available at no charge and is capable of running on GNU Linux, Windows, and Mac OS X. The OpenEHR Foundation is an international, not-for-profit organization working toward the development of interoperable, lifelong EHR. However, it is also looking to reconceptualize the problems of health records, not in narrow IT implementation terms, but through an understanding of the social, clinical, and technical challenges of electronic records for healthcare in the information society. OpenEMR. It is the most popular open source electronic healthcare records and medical practice management solution. OpenEMR's goal is a superior alternative to its proprietary counterparts with passionate volunteers and contributors dedicated to guarding OpenEMR status as free, open source software solution for medical practices with a commitment to openness, kindness, and cooperation. OpenMRS. It is a community-developed, open-source enterprise EMR system platform of particular interest to this project is supporting efforts to active build or manage health systems in the developing world to address AIDS, tuberculosis, and malaria, which afflict the lives of millions. Their mission is to foster self-sustaining health IT implementations in these environments through peer mentorship, proactive collaboration, and a code base equaling or surpassing any proprietary equivalent.